1. NASA's Hubble and Webb reveal stunning star clusters in the Small Magellanic Cloud. 2. Hubble and Webb reveal stunning star clusters, NGC for 60 and NGC for 56 unveiled. 3. Hubble vs. JWST, how two space telescopes reveal cosmic secrets. 4. Webb and Hubble telescopes reveal stunning star clusters together. 5. Hubble and Webb team up, revealing hidden star formation in the SMC. 1. NASA's Hubble and Webb reveal stunning star clusters in the Small Magellanic Cloud. Imagine peering into the cosmic cradle of star formation, where galaxies like the Small Magellanic Cloud are bustling with activity. NASA's Hubble and James Webb telescopes have unveiled stunning visuals of two open star clusters, NGC for 60 and NGC for 56, nestled within this dwarf galaxy orbiting our Milky Way. These images aren't just beautiful, they are a window into the dynamic dance between stars and interstellar gas. But here's where it gets fascinating: the collaboration between these two telescopes reveals details that neither could capture alone. The image combines data from Hubble's visible light observations and Webb's infrared capabilities, creating a vivid tapestry of cosmic activity. NGC for 60 and NGC for 56 are part of the sprawling N83-84-85 complex, a region known for its intense star-forming processes. These clusters, only about 10 million years old, are like newborns in the universe's timeline, offering scientists a rare glimpse into the early stages of stellar evolution. Here's the catch: stars aren't the only stars in this story. The interplay between glowing gas and dust clouds is equally critical. Hubble's visible light captures the ionized gas that glows blue, shaped by powerful stellar winds that carve bubbles in the surrounding material. Meanwhile, Webb's infrared view highlights the dust itself, revealing intricate filaments and clumps that emit a warm red glow. This dual perspective isn't just visually striking, it's a scientific goldmine. But this is the part most people miss: the dust isn't just a passive backdrop. It's actively heated by nearby stars, and its distribution can tell us a lot about how stars form and influence their environment. Scientists are especially intrigued by O-type stars in the N83-84-85 region, massive, super-hot stars that are incredibly rare. In the entire Milky Way, which holds 400 billion stars, there are fewer than 20,000 of these blazing giants. Their presence here raises big questions: how do such extreme stars shape their surroundings? And what does their rarity say about the broader processes of star formation? This discovery isn't just about pretty pictures. It's a reminder of how much we still have to learn about the universe. While Hubble and Webb have given us unprecedented clarity, there's still debate over how exactly these clusters formed and how their unique conditions might differ from those in our own galaxy. What do you think? Do you believe the Small Magellanic Cloud's star-forming regions are fundamentally different from ours, or are they just a more extreme version of the same processes? Share your thoughts below. Science thrives on curiosity and discussion. PhD in Technical Sciences, graduated from Kharkiv National University of Civil Engineering and Architecture with a degree in Technology of Building Structures, Products, and Materials. Since 2013, he has been popularizing science in Ukrainian through dozens of public lectures and articles in science media such as nowka.ua, uageek.space, scienceukraine.com, MyScience, and others. He participated in projects like 15x4, Free University Maiden Monitoring, Pre-Post, and more. Previously, he wrote about paleontology, archaeology, biology, geography, and history, but in recent years, he has focused entirely on astronomy and space, author of around 15 academic publications, participant of the 31st Young Scientists Conference on Astronomy and Space Physics, 2025, and nominee for the Eurocon 2022 award for a series of online articles about spaceflight. He values respect for scientists and engineers behind every discovery and mission in his work. Google Scholar, https:// scholar.google.com/citations user $WCHX-GAAAJ&HL =RU, https://orchid.org/org/0002-0002-6762-434x. 2. Hubble and Webb reveal stunning star clusters, NGC for 60 and NGC for 56 unveiled. Prepare to be amazed by the cosmic ballet unfolding in the depths of space, where NASA's Hubble and Webb telescopes have unveiled a stunning duality within a pair of star clusters. But here's where it gets mind-blowing. These clusters, NGC for 60 and NGC for 56, aren't just dazzling to look at, they are a living laboratory for understanding the early universe. Nestled within the Small Magellanic Cloud, a dwarf galaxy orbiting our Milky Way, these open clusters are home to thousands of young stars, all loosely bound by gravity. What makes this discovery even more fascinating is how these stars are born from collapsing gas clouds, their intense stellar winds sculpting the surrounding nebulae and triggering a chain reaction of star formation. It's like watching a cosmic domino effect in action. In these images, Hubble and Webb offer two distinct perspectives. Hubble's view captures the glowing, ionized gas, in blue, as stellar radiation carves out bubbles in the clouds, while Webb's infrared vision reveals the intricate, filamentary structures of dust, in red. And this is the part most people miss. While Hubble often shows dust as dark silhouettes blocking light, Webb's infrared gaze makes the dust, warmed by starlight, glow with its own radiant light. This interplay of gas and dust, known as the interstellar medium, is the very cradle of star formation. The nodules you see in these images are bustling hubs of starbirth, with stars as young as 1 million years old, mere infants compared to our 4.5 billion-year-old Sunday. The region, called the N83-84-85 complex, is also home to rare O-type stars, massive stellar giants that burn hydrogen at an astonishing rate. With only about 20,000 of these stars in the Milky Way's 400 billion star population, spotting them here is like finding a needle in a cosmic haystack. Here's the controversial part. The Small Magellanic Cloud, with its lower metal content compared to the Milky Way, offers a glimpse into the early universe's conditions. Astronomers call elements heavier than hydrogen and helium metals, and this dwarf galaxy's metal-poor environment mimics the cosmos' infancy. But does this truly replicate early cosmic conditions, or are there nuances we're missing? Researchers aim to use these observations to study gas flows, refine the collision history between the small and large Magellanic Clouds, and explore how gravitational interactions between galaxies spark starbursts. It's a bold endeavor, but one that could rewrite our understanding of the interstellar medium and star formation. So, what do you think? Does the Small Magellanic Cloud hold the key to unlocking the universe's earliest secrets, or are we oversimplifying a far more complex cosmic story? Share your thoughts in the comments. Let's spark a conversation as vast as the stars themselves. 3. Hubble vs. JWST, How Two Space Telescopes Reveal Cosmic Secrets. Imagine the incredible power of combining not just one, but two of the most advanced space telescopes ever created. Could this be the ultimate approach to exploring our universe? While the Hubble Space Telescope has revolutionized our understanding of space over the past 35 years, the James Webb Space Telescope, JWST, launched in December 2021, pushes the boundaries even further with unmatched complexity and sensitivity. When these two giants work together, their combined capabilities produce a synergy that greatly enhances scientific discovery while also offering breathtaking images of the cosmos. An excellent example of this collaboration is a composite image showcasing two open star clusters, NGC for 60 and NGC for 56, in the Small Magellanic Cloud, SMC, a nearby dwarf galaxy. Both clusters are adorned with glowing nebulae, showcasing how matter and energy create spectacular natural phenomena in space. Examining side-by-side photos of NGC 456 from both telescopes reveals fascinating differences. The Hubble image, captured using its advanced camera for surveys, spans ultraviolet to near-infrared light, showcasing a bright, fluffy cloud of ionized gas highlighted in blue. In contrast, JWST's NIRCam instrument emphasizes the dust that outlines these gaseous structures, revealing delicate filaments and clumps in red. This comparison illustrates how each telescope's unique technology provides complementary insights, with Hubble focusing on ionized gases and JWST revealing dust structures heated and glowing in infrared. The Small Magellanic Cloud is a particularly intriguing region for astronomers because of its low metallicity, that is, its scarcity of heavy elements. This characteristic makes it similar to the early universe, before massive stars brewed and dispersed these elements into space. Studying the SMC allows astronomers to observe conditions akin to those just after the Big Bang, giving a preview of how the first stars and galaxies might have formed billions of years ago. However, the real magic happens when combining images from both telescopes into a single, detailed composite. In the case of NGC 460 and NGC 456, this creates a stunning 527 megapixel mosaic assembled from 12 overlapping observations that encompass both visible and infrared light. This detailed view reveals not just what the stars and nebulae look like, but also hints at their interactions and origins. Stars in these clusters begin their life when massive clouds of gas and dust collapse under gravity, forming dense stellar cores. Over time, these cores gather more material until nuclear fusion ignites, starting their life cycle as bright, hot stars. These young stars emit intense radiation and winds that carve bubbles and cavities in the surrounding gas, triggering further star formation like cosmic spark plugs. The process is cyclical: the radiation blows bubbles, the winds compress nearby gas, and new stars continue to emerge. Zooming into specific areas of NGC 460 and NGC 456 reveals the intricate structures of the interstellar medium, the mixture of gas and dust that fills the space between stars. Hubble's images tend to show glowing ionized gases, highlighting how stellar radiation distorts the clouds and creates visually captivating blue bubbles. JWST's infrared view, however, uncovers the dense dust clouds, revealing their delicate structures and revealing dust that is warm and glowing due to stellar heating. These differences help scientists understand the physical processes shaping star-forming regions. Most stars in these clusters are extraordinarily young, only about 1 to 10 million years old, mere infants compared to our Sun's 4.5 billion year lifespan. These clusters are nested within an even larger complex known by the less memorable name N83-84-85, located within the inner wing of the SMC. This area contains many OB associations, groups of massive, hot stars. These OB stars are crucial drivers of cosmic change. Many will explode as supernovae, releasing energy that stirs up the surrounding interstellar medium and sparks new waves of star birth. Observing these processes in the SMC gives astronomers a rare glimpse into the feedback loop that has shaped galaxies since the universe's infancy. And here's the part most people miss: anyone with internet access can download this enormous, detailed image and zoom in to explore the intricate tapestry of stars, gas, and dust. It offers a unique opportunity for enthusiasts and scientists alike to get up close and personal with the universe's creation process. You can find the full mosaic and delve into its details here. https://science.nasa.gov/missions/hubble/missions/hubble-webb-reveal-2-phases-of-star-cluster-duo. But here's where it gets controversial. Does combining the strengths of multiple telescopes truly revolutionize our understanding more than investing in a single, groundbreaking instrument? Or are these collaborative efforts just showcasing pretty pictures, while the real breakthroughs happen behind the scenes? Share your thoughts. Do you believe this synergy will fundamentally change astronomy, or is it mainly for visual impact? Let the discussion begin. 4. Webb and Hubble telescopes reveal stunning star clusters together. Did you know the universe is hiding secrets in plain sight? While many of us scroll through daily horoscopes, NASA's telescopes are busy painting a picture of cosmic wonders that could change how we see the stars. Welcome to the Tuesday Telescope, where we swap astrology for astrophysics and explore the breathtaking beauty of the cosmos. Open star clusters, those sparkling groups of stars born from the same cloud of gas and dust, are like celestial time capsules. Imagine a family of stars all created at the same time, but with different sizes, colors, and lifespans. By studying these clusters, astronomers can essentially watch a star's entire life story unfold in one place. It's like comparing siblings in a family photo, but for stars. The Pleiades, or Seven Sisters, are a famous example, glowing 444 light-years away like a jewel in our night sky. But some clusters, like NGC 460 and NGC 456 in the Small Magellanic Cloud, are so far away they feel like whispers from the edge of the universe. Here's where the real magic happens. NASA's Hubble and James Webb telescopes have teamed up to reveal these clusters in two completely different ways. Hubble, the veteran observer, captures the vibrant glow of ionized gas. Think of it as the universe's neon signs, lit up by the fierce radiation of young stars. Webb, the newcomer with infrared superpowers, peels back the layers to show delicate threads of dust and hidden structures that Hubble can't see. When they combine their data into a single image, it's like getting a 3D view of a starry puzzle. The result? A stunning mosaic built from 12 overlapping observations, revealing details that would be impossible to spot with just one telescope. But here's where it gets controversial. Some astronomers argue that relying on multiple telescopes might overcomplicate things. Others say it's the only way to truly understand the universe's complexity. And this is the part most people miss: these images aren't just pretty pictures. They are clues to how galaxies form, how stars die, and even the history of our own Milky Way. So, what do you think? Do you believe the collaboration between Hubble and Webb is a game-changer for astronomy, or is it just a flashy tech showcase? Share your thoughts below, because the universe doesn't have a single answer, and neither does this debate. 5. Hubble and Webb team up, revealing hidden star formation in the SMC. Imagine peering into the depths of space and witnessing the raw beauty of star formation. Two of humanity's most advanced telescopes have done just that, unveiling secrets hidden for billions of years. On July 7, 2025, NASA released a breathtaking set of images captured by the Hubble and James Webb Space Telescopes, showcasing two star clusters, NGC 460 and NGC 456, nestled within the Small Magellanic Cloud, SMC. This dwarf galaxy, which orbits our Milky Way, is like a cosmic time capsule, offering scientists an unparalleled look at how stars form and evolve in environments similar to those of the early universe. But here's where it gets fascinating: these telescopes don't just work independently, they team up, combining their unique strengths to provide insights that neither could achieve alone. The collaboration between Hubble and Webb represents a monumental leap in our ability to study the cosmos. Hubble, with its mastery of visible light, captures the vibrant glow of ionized gas surrounding these star clusters. Picture this: massive clouds of gas illuminated in brilliant shades of blue, shaped by the intense radiation emitted from young, energetic stars. These glowing bubbles are not just visually stunning, they reveal the dynamic interaction between stellar winds and the surrounding interstellar medium. Meanwhile, Webb steps in with its infrared vision, piercing through the thick veils of dust that often obscure key details in visible light images. By detecting the faint heat signatures of dust grains heated by starlight, Webb uncovers intricate structures like delicate filaments and dense clumps, regions where new stars are actively taking shape. This dual perspective allows astronomers to piece together a fuller picture of the processes driving star formation. The Small Magellanic Cloud, with its relatively low metallicity, a term astronomers use to describe the abundance of elements heavier than hydrogen and helium, serves as a natural laboratory for studying conditions akin to those in the early universe. In such environments, star formation can proceed differently than in galaxies like ours, making the SMC a critical testing ground for theories about the life cycles of stars and galaxies. And this is the part most people miss: while the images may seem like works of art, they are also treasure troves of scientific data, shedding light on everything from the chemical makeup of distant nebulae to the role of magnetic fields in shaping the cosmos. Star clusters themselves play a pivotal role in unraveling the mysteries of the universe. Take NGC 460 and NGC 456, for example. These open clusters consist of anywhere from dozens to thousands of stars bound together by gravity, all born from the same colossal cloud of gas and dust. Unlike globular clusters, which contain ancient stars dating back nearly to the dawn of the universe, open clusters like these are youthful, with ages ranging from 1 to 10 million years, youngsters compared to our suns for 0.5 billion year lifespan. This youthfulness makes them ideal subjects for studying the early stages of stellar evolution, including phenomena like stellar wind emissions and nuclear fusion reactions. These processes sculpt the surrounding environment, creating feedback loops that influence future generations of stars. Among the stars in these clusters are some of the rarest and most awe-inspiring objects in the universe, O-type stars. These behemoths are incredibly luminous and burn through their fuel at astonishing rates, living fast and dying young in astronomical terms. Their brief but dramatic lives offer clues about the explosive cycles of star formation that have shaped galaxies throughout history. Without these short-lived powerhouses, we wouldn't fully understand the mechanisms driving the birth and death of stars across the cosmos. But let's dive deeper into the controversy. What happens when the dust and gas that give rise to new stars run out? Does star formation simply cease, or do other factors come into play? Some researchers argue that the interplay between stellar winds, supernova explosions, and galactic mergers might reignite star-forming regions long after they've appeared dormant. Others contend that once the resources are depleted, the process ends permanently. What do you think? Could there be unknown forces at work sustaining star formation in unexpected ways? In conclusion, the combined efforts of Hubble and Webb have given us more than just stunning visuals. They've opened a window into the very heart of the universe's creative engine. From the glowing gas clouds captured by Hubble to the intricate dust structures revealed by Webb, each image tells a story of birth, growth, and transformation on a cosmic scale. As scientists continue to analyze the data, one thing is clear: the universe still holds countless secrets waiting to be uncovered. So, tell us, what aspect of star formation intrigues you the most? Share your thoughts in the comments below.